For this video, we will see what happens to the particles in a substance during expansion and contraction. We will visit what is meant by expansion and contraction of a substance and use SAMEF, space, arrangement, movement, energy and forces of attraction to explain what happens to the volume during expansion and contraction. Before that, we need to understand what is meant by conservation of mass. The law of conservation of mass states that the mass is neither created nor destroyed. This means that the particles in the substance cannot magically appear or be erased or removed. Before that, can you recall what is meant by mass? A mass is the amount of matter in a substance, and matter is made of particles. Hence, mass refers to the number of particles in a substance. Based on the law of conservation of mass, the number of particles, which is related to mass, does not change. So what is expansion? A substance is said to have expanded when it has increased in volume. So what do we see every day that involves expansion?
Oh.
Hey, did you notice that the level of mercury in the thermometer rose when it was placed in hot water? You must be wondering why this happened, right? It happened because of thermal expansion. Thermal expansion is the tendency of matter to expand on heating. This tendency of expansion can be observed in solids, liquids, as well as gases. Now, let us see how this concept of thermal expansion applies to a thermometer. A thermometer usually consists of a narrow tube with a small bulb at its one end. The bulb and a part of the narrow tube is filled with mercury, which is liquid at room temperature. Now, when a thermometer is placed in hot water, mercury inside it expands due to thermal expansion, and as a result, its level rises.
Ah! Huh?
You must be thinking how the gasoline came out of the tank, even though it was exactly filled till the brim. Am I right? Gasoline also expands on heating. So, what happened is that when the tank was filled till the brim, there was no space left in it. Now, when the bike was kept in the sun, the tank became hot, which eventually heated the gasoline filled in it. As a result, the gasoline expanded. But since there was no space left in the tank, expansion forced gasoline to come out of the tank. Do you think that the rails bent because of thermal expansion? If yes, then you are absolutely correct. A railway track is made up of a number of rails joined to each other. These rails are usually made up of steel. Steel expands on heating and contracts on cooling. When the rails are joined to one another without leaving any space for expansion, the rails bend due to thermal expansion and the train goes off the railway track. To avoid this, the rails are not joined together firmly. Instead, each rail is connected to the other in such a way that a small gap is left in between them. These small gaps provide space for easy expansion of the rails, which happens due to continuous friction between the train wheels and the rails. Hence, these small gaps prevent the rails from bending, preventing any kind of accidents.
Let us just recap what is meant by expansion. A substance is said to have expanded when it has increased in volume, and a substance has contracted when it has decreased in volume. So as you can see in this picture, when it's cold or when it's contracted, the size of the metal bar has decreased. The volume of the metal bar has decreased. When it has expanded, the volume of the metal bar increased. What happens to the particles during expansion and contraction of a substance? Let us look at the particles in a solid closely. Imagine that the forces of attraction keeping the particles closely packed are springs. So if we look at these two particles and we magnify it, okay, this is the forces of attraction holding them together. It's like a spring. Why do we liken it to a spring? Because if you recall, the particles are always vibrating. At higher temperature, the amount of energy possessed by the particles are higher than at lower temperature. So at higher temperature, it possesses larger amount of energy. As a result, the particles at a higher temperature vibrate with more energy and over a larger distance. So you can see that it covers more distance than if it's at lower temperature. Because lower temperature, it possesses a smaller amount of energy. For example, just like on a cold rainy day in a classroom, most of you will be very sleepy and fidgeting in your seats. Versus when it's a warm day, many of you will be fidgeting more and reaching out to your friends over at the other table. You'll be moving around more when it's a hotter day. So when it's hotter, you have more energy and you will move more. When it's lower temperature, you have lesser energy, you will move less. When the temperature increases, the particles gain energy and move further away from each other. So they cover more distance. Okay, so please fill in the blanks inside your notes as well. The distance between the particles then increases and the volume it occupies will also increase. Hence, expansion occurs. However, please note that the density decreases. This is because density is equal to mass over volume. Now we know from the beginning of the video, mass does not change. But because it covers a bigger distance, the volume will become bigger. It increases. As a result, the density becomes smaller. Okay, what happens when the temperature decreases? So when it decreases, the particles lose energy and move closer to each other. The distance between the particles then decreases and the volume it occupies decreases. Hence, contraction will occur. However, please also note that the density here increases because the mass remains the same but the volume decreases. Right, let's have a quick check. Answer these questions on your own and your teacher will go through them with you in the follow-up lesson. Let's have a summary. During expansion and contraction, only the distances between particles change. So highlight these two keywords. The size and the mass does not change because of law of conservation of mass. The mass of the substance remains the same, although the volume changes when it expands or contracts. Mass remains the same, volume changes. So please complete this quick check as well, and your teacher will go through them with you in class. And this quick check as well. If you have any questions, please feel free to comment or ask your subject teachers when you see them in class. Alright, that's all. Thank you. Bye-bye.